Loading information into a complex system with knowledge graphs and vector DVs, and then querying that system can be intimidating and difficult to build and difficult to understand. Today, I'm going to show you with the new configuration portal and our latest version of the data workbench, how simple we make this process in TrustGraph. First, let's start off in the configuration portal. I already have a configuration set. We're going to use Google AI Studio. Our default graph store, Cassandra, which really isn't a graph store, but that's a whole nother subject. Have all these settings. The only thing that's a little bit different now is when you go to customization, we see this tab, the data workbench, is which is already turned on, but I'm going to toggle it back on. So as you probably remember, these tools allow you to customize other elements of TrustGraph. But this one will now deploy the data workbench when you deploy TrustGraph. There's no other selection, there's no other customization required, no other settings that need to be made. We just toggle it on. And when we come here to finish our deployment, we'll see the generate button, which we're accustomed to. We click that, it creates the files. But then we see this. This is telling us that when we deploy, that the data workbench will be available at this port. Now, I've already deployed TrustGraph, I've already set it up, and it's already running. And we can come here, and this is the new look data workbench. This allows us to perform a graph rag query using chat. We have a semantic similarity search, and then we have the ability to explore and visualize the data. Now, this is where we load data. We can do batch loading, or you can do one at a time so that you can actually create document level metadata for each document, which is what I've done here. I've taken the Rogers Commission report for the NASA Challenger disaster, which is a document that we know really well. And I put the metadata information in. I've already loaded it, as you can see. It's already processing. So if we ask it a question, for instance, if I ask, who were the crew of the Challenger? Actually, I had it right the first time. This is actually performing a graph rag query. And this will actually now give us the information from the document that's taken. This is the people that it extracted as being the crew members. Now, over here, we can see more information that we can now explore. We can explore this concept, just the Challenger mission, which we now see these are actually relationships. We see Challenger space mission that experienced an accident. We see that it's a subject of the Rogers Commission report, which is the metadata that I gave to define the document. We see other ones. We can explore any of these. We can also explore one of the crew members. And if we take this, and now we decide to do the graph view, we can now see a 3D graph visualization. We can zoom in, we can take a node, we can drag it. We click on one of the relationships, we'll see the directionality. If we click on any node, it'll expand if there's more information here. Let's see if we can pick a topic. Let's see if we pick this one, what we will get. I know this one is going to have quite a bit of information that's going to clutter the screen quite a bit. So here's one, the solid rocket booster. This is a good example. We zoom in, we can see the relationships. See, we expand that, we can see more. What's interesting is if we go to semantic search, let's see, what were we looking at that for? We were looking at, if we do solid rocket booster there, we're going to see slightly different results. So this is actually going to return a list of the semantic similarity scores as opposed to actually querying the knowledge graph. This can be useful for seeing the differences between what happens when you perform a graph rag query and how this compares. So this kind of makes sense. We see that we have a very high similarity score for things like solid rocket booster, solid rocket booster project manager, but then all the way O-ring, very, very low, even though we know that the O-ring is conceptually related to the solid rocket booster. But if you were just relying on a semantic similarity, then you wouldn't return that relationship necessarily. But if we go to O-ring, we can see all the relationships. We can already see a lot of the key topics that if you're familiar with the Challenger, that you already realize that these are the topics that are directly relevant to what happened with that mission. Another interesting one is if we just search for crew. What happens if we search for crew? Because we saw if we did a graph rag query, it would actually respond with the crew members. But what do we get with crew? With slightly different results. We get some of them, but it's not exactly the same because semantic similarity of the word crew isn't going to necessarily return who were the crews of the mission, which we did right here. Who were the crew of the Challenger? So this is just a way that now with the data workbench, we can use all of these tools at our disposal to understand the data set. We can form graph rag queries. We can see the semantic similarity scores, and then we can actually see the relationships and then visualize them in 3D.